So in any complex K, we have 0 simplices, 1 simplices, K simplices. So let's say this complex is K, and any complex we have 0 simplices, which are nothing but singleton sets. Then we have 1 simplices, so on till K simplices, small k. So if from here we can say that the maximum dimension of a particular simplex in this complex is k, because beyond k we don't have any simplex in this complex. If we take an example, let's say the vertex set is v0, v1 and v2. If we write a complex k on this particular vertex set, then we will first include those 0 simplices, that this is v0, v1, v2, and then we have 1 simplices, v0, v1, v0, v2, v1, v2, and then we have 2 simplices. So 2 simplices, that is only v0, v1 and v2 here. So these are 0 simplices. All these are 1 simplices, and this one is our 2 simplex, right? So depending upon the range number of vertex that you have in the vertex set, you can have as many as simplices in your complex K, right? So that is clear to us. Now we will move on and define a new term, which is chain group. So basically this chain group is defined by taking a particular complex K only. So one thing is sure, that this chain group is defined over particular complex K. Also, it is defined for particular dimension or particular type of simplices. So defined over particular dimension. So in this simplex we have dimension 0, we have dimension 1, and we have dimension 2. So you may take any one dimension and this complex, over that we can define a chain group. Now how do we define it and what exactly it is? Actually it is a vector space. Chain group is a vector space. This chain group is nothing but a vector space. And we know that in any vector space we must have some basis over that we can generate the vectors, right? So if I take particular complex K and if I take a particular dimension, let's say small k, then what will be my basis? Those basis will be my K simplices. For example, if I take complex K, which is this one only, let's say this, I take this complex K, and if I take dimension small k equal to 2, then these v0, v1, v0, v2, v1, v2, will become my 3 bases. So in that case, my basis will be v0 v1, v0 v2 and v1 v2. Now using these 3 bases, I can generate more vectors in this particular chain group. And how do we denote this chain group? To denote this chain group, we use capital letter C, and to specify that it is from particular complex K, we write like this: C of K, and in subscript we have small k. So it is denoted by C subscript small k of complex K. So here this small k means dimension, or I can say K simplices, and this capital K means it is defined over complex K, and C is the letter which we use to denote this vector space, right? So how many chain groups are possible? How many chain groups are possible for this particular complex K? For this complex K, we have 0 simplices, 1 simplices and 2 simplex only. So for this particular K, we have C0K, C1K and C2K only, right? In C0K, what will be my basis? So what are bases here in C0K? Bases are V0, V1, V2, basically all the 0 simplices. In C1K, what are my bases? Bases are V0, V1, it is one base, then V0, V2 and then V1, V2. So 3 bases I have in this C1K vector space. Similarly in C2K vector space, what are my bases? We have only one base, that is V0, V1 and V2. Now using these bases, I can generate all the other vectors in this particular vector space. And we know that to generate vectors by using the bases, what we do the linear combination. We do the linear combination of the bases and we generate the vectors, right? So to get any vector gamma, so any vector gamma in vector space Ck of capital K, here small k and here capital K, subscript small k, and in bracket we have capital K. So to get any vector gamma in vector space Ckk, you can take linear combination of its k simplices, right? So gamma will be equal to summation of, let's say coefficients are denoted by again let's say alpha denotes the coefficients, and here we have sigma, and I'm summing over all the k simplices over this particular sigma, right? One example here in basis, for this C0K, I can have one vector can be V0 plus V1 plus V2, where I have taken coefficient as 1 for each plus 1 plus 1 plus 1 coefficient for each vector, for each base. So for each base I have taken plus 1 coefficient, and by taking the linear combination I got this one particular gamma. one particular vector. This particular vector in vector space is also called a chain. Also, you must be wondering that from where we are taking these coefficients, like how, which coefficients to choose, what is there any restrictions over taking these coefficients? Yes, there is. So basically we take these coefficients from a field f, and that field may be of your rational numbers, or that may be of your real numbers, or that may be from zp. So basically in zp we have numbers from 0 till p. For example, if p is 2, then we have 0 and 1 only, right? So whatever exceeds 1, we take modulo 2 in that case, or if it's any p, we take modulo p in there, right? So 1 plus 1 is 0 in z2. So this depends upon your definition. How do you define coefficients for your chain group?